Alright guys, so we did the first part of this on Tuesday, which was the upper part of the oven. This is the second part. We're going to talk about the oven schematic and some of the components on this unit. I don't know if you guys remember, but there was a mistake in the wiring diagram. Does anybody remember the mistake that we found in this wiring diagram?
Up top over there in the right hand corner.
Okay, up here?
Yes, sir.
What was wrong with it?
I think they wired it with line. I think it was the neutral was going over there.
Well, line 1 comes in,
Right.
and it goes through here, and it goes to this relay right here. And one says BR and one says BA. What do you think that is? BR and BA?
Brown.
Nope.
Back from bake.
Bake?
Bake and broil.
Okay.
Okay.
So that's a relay switch right here, and that's a relay switch. Notice the Broil Relay. What type of contact is that right there on the relay?
That's a normally open contact?
Nope. That is a single pole, double throw. That's a single pole, single throw. So the bake relay is only got a single switch. The broil relay can go down here or up here. It can go down or up. It has 2 different positions on the relay. Okay? And we'll go through those circuits in a minute as we explain each diagram. But let's take a look at what did they do wrong here. Is that this is line 1. It goes to the relay, but it also comes off the relay and goes to the transformer. And then the other side of the transformer should be neutral, where it goes to the other light. Neutral's over here. They didn't draw that right. So if we look, this side of that transformer coil there should be coming here and going to neutral. They have line 1 and neutral connected together on the diagram. And that's power coming into the board to light up the board. So let's take a look at something here. We're going to come back a second. Can you guys see where I redrew the diagram and corrected the circuit? Take a look at the differences between the two. Have you ever seen like pictures and you see one picture and the other picture, say what's the differences in the picture? Which one is the correct one, the upper one or the lower one?
Hold on a minute. The lower one is the correct one.
The lower one is the correct one. Very good. So if we look, line 1, which is black, is coming in here and goes to the transformer and then comes out here, out the neutral. That's the way it should have been drawn. Now if you look here, they connected line 1 also to the light switch, and coming out here is the light switch. And if we look at the full diagram, if this was line 1 coming to the light switch, it goes to the light bulb, and look, the light bulb ends at neutral. That would make sense. So this is an incorrect drawing. This is the way the factory did it. So in the handout that was given to you, I just opened up the PDF and copied it onto this schematic. I didn't draw it wrong on purpose. It was drawn wrong from GE. A lot of times manufacturers do make mistakes and you have to try to figure it out. One time I went to a customer's house, and I think I've told this story 100 times before. It was a slide-in range. And another technician before me from Sears ordered the thermostat for it. So I knock on the door, and the lady says, "What are you doing with that box?" I says, "Well, the guy ordered the part. I'm here to put the part on." She goes, "I don't want this stove. Every time they put it on, it blows up." Now, she only had the stove for a couple of weeks. And I said, "Well, can you tell me what happened?" She says, "Well, when I put it in the self-clean cycle, it blows up." And I'm like, "Okay, well, give me a chance. Let me check it out." So I went to the stove, and on the slide-in range, if you lifted up the top here, underneath the top was the wiring diagram. It was glued inside. So that came with that stove. But the controls, instead of being up here, they were in the front of the unit. So I went ahead and I started looking at the old thermostat, the one I had in my hand, and I'm going, red goes to number 1 and black goes to number 2, and I'm wiring it all up. So as soon as I said, I got a color here on this number that's not on the wiring diagram, something's wrong. So I went ahead and turned the oven on and the bake worked. As soon as I went to self-clean, bam, it blew up. And I'm like, the diagram can't be right because I got a color on this stove and a terminal on the switch. It's not on the diagram. And this is back in the 80s when I started working. I may have only been for Sears for about a year or something like that. So I got a piece of paper and a pencil and I put the selector switch on bake and I ohmed out every possible switch that could be closed and I made a chart and I broil, clean and everything. And I drew an entire diagram of that oven. So I went back to my boss at Sears and I said, listen, this diagram is not the right diagram. I said, here's the diagram for the stove. He's like, where'd you get that? I said, I drew it. He's like, you drew that? And I'm like, yeah, I drew it. I looked at every wire and I drew out every switch and every terminal on the thing. And I said, we need a new switch because that one blew up. But I need the diagram. He says, oh, we're going to have to call the factory, get factory. Back in the 80s, we didn't have internet. We didn't have computers or cell phones. You know, we still use pay phones. So he had to order from the factory. So I'm driving to the Keys. I service the Keys twice a week. And on the way back, Cutler Ridge was a Sears store. And I'm thinking, man, she only bought this stove 4 weeks ago. I drove into the store. And the guy says, can I help you? The salesman, no, I got my Sears uniform on. I'm just going to look at the stove. So I lift up the top, and there's no diagram in there. But the other stove, it was glued in there. So I slid it out. In the back of the stove was a little pouch with the diagram, and I looked at it, and I'm like, damn, okay. So I start walking. He goes, where are you going with that? I said, I'm going to the back of the store. I'm going to make copies of the diagram. So I made a couple of copies, went back, put the original back on the floor model. And I went back to my supervisor. It was the very next day. I went back to my supervisor, and I said, hey, I got the diagram for the stove. He's like, where'd you get that? I stopped by the store and took it off a floor model. He's like, oh. And he looked at it, and I only had 2 wires backwards from my drawing that I hand drew the day before. He's like, Zilka, if all my techs could do this, you don't have to do that all the time when you're troubleshooting, but you have to understand the schematic. If you don't understand what's going on, you can't troubleshoot. And everybody says, how do I study? I sit there and I look at the diagram and I look at the diagram, and they're like, I don't know how to study the diagram. I'm just looking at lines. And you just got to trace circuits like we did a minute ago, but you have to trace them and compare them to the actual machine. Like, let's take a look at this diagram, and I put the corrected one on there, right? Is that the corrected one?
Nope.
No, that's the wrong one, right?
Mm-hmm.
Okay, so I'm going to take it off for a second. I just want to see if you guys are paying attention. Let me cut this one. I go to this page here, and that's not the correct one either. This one is the correct one. Let me erase this. Hold on. So here is the control board on this stove. I took a picture of it so that you guys can look at it and look at the diagram. The first thing well look at is this plug right here. Is this plug right here. Mm-hmm. Notice there's only 2 wires coming off the first 2 pins. Mm-hmm. And there's only 2 wires coming off the first 2 pins. There's 1, 2, 3, 4, 5 holes and 5 circles there. So these 2 wires, white, go to what? What does that go to?
The oven temperature sensor.
The oven sensor. And what should the reading be?
1100 ohms.
1100 ohms at room temperature, about 2600 ohms at self-cleaning temperature. So let me ask you a question. Is that an NTC or PTC thermistor? Go ahead, Julio, you want to answer it.
Is it a PTC?
Very good, Gerald. It's a PTC. NTC and PTC. I say it all the time. PTC is positive temperature coefficient. NTC would be what? If P is
Negative.
positive, N is what?
Negative.
Negative temperature coefficient. So what that means is if that thermistor, if the temperature rises, like in an oven, when we turn it on, what happens to the temperature? It goes up. PTC means the temperature and the resistance go together. If the temperature goes up, the resistance goes up. Temperature goes down, the resistance goes down. So positive is they're both together. What does negative mean?
I'm going up and I'm going down.
One is up and one is down. If I gave you a photograph and I gave you a negative of the photograph, it would be opposite. And think of it that way. So NTC is when the temperature goes up, my resistance would go down. You find those mainly on refrigeration or units that do cooling, air conditioned refrigeration. But this PTC, because at room temperature, we're talking about 70 to 80 degrees. Self-clean, I mentioned the other day, is about 850 degrees. And you see how the resistance went from 1100 to 2600. So that's how you know it's a PTC relay. I'm sorry, PTC thermistor. So let's take a look at this circuit here. We said black was line 1 coming in, remember?
Mm-hmm.
And it went to the relay right there.
Mm-hmm.
So over here, if we look at the relays,
Second from the right.
this one right here, this wire, this black wire right here, is this black wire coming into that relay. So that means, what is relay A? Which one is that? According to the schematic, which relay is it?
It's the bake relay
How do you know it's the bake relay?
because it says BA on the schematic.
It says B in a schematic if we're looking at it physically, but what if they weren't drawn physically in that order? How would you know for sure? Let's just say they drew it here, but it was really that one over there. How would you know that that is the bake relay?
Okay, because I see only one wire going to that bake relay.
Well,
Yellow wire.
what color wire?
Yellow.
Yellow wire. You see a yellow wire coming off that relay, and you see a yellow wire coming off that relay there. So that's how we identify it. We find the color going to that part. We find that color going to that part on the diagram, and we tie those two together. What about the broil relay? Which one is the broil relay?
One right there where that red wire, where that black wire is coming
C.
from. C.
Black wire on one side, and then broil is coming to purple. So this is going to what? What does that purple wire go to?
Probably going to
The broil element in the oven.
yeah.
So if we looked here on the stove, this yellow wire here runs down to the bake element in the back of the stove. This purple wire here runs down, goes to our broil element. So that's what these two wires are here, the purple and the yellow.
Okay, so now what about that orange wire? I mean, you have two wires going to that bake, to the both bake and the broil element, because when we change out these elements, right? These two wires have to be disconnected, so this is neutral right here, right?
No. If we looked, slide back a little bit so everybody can see. This I haven't got to yet, but this is your oven sensor.
Okay.
How do I know? Look at these two wires. Where do they go?
White, right there.
They go right here, and they're white and white going to the oven sensor. So that's very weird that they put the oven sensor right there by the element. That actually can cause the oven to short cycle, and I'll explain that in a minute. Most of them, they put the thermistor on one of the corners, far enough away from the element, because remember, the sensor senses the temperature of the oven. They physically mounted this sensor to the heating element. If we look inside, and I'll go to a picture here. I took a picture of it because I knew we were going to discuss it. They put the sensor right there where the element is.
Mm-hmm.
Well, when the elements come on, even though we put the oven at 300 degrees, the elements themselves get hotter than 300. So they can cause short cycling or that part to fail. That's really weird that they put that oven sensor there. I've never seen that before on any other stove. They usually put that over here in the corner by the light bulb. Okay? But this one here, oddly enough, that's where it is from the factory. Okay? So let's go back to this diagram here. So you were asking about the orange wires. Now if I go to the full diagram, if we look at the broil element and the bake element, they both connect to a single wire, which is what? Orange. Now, if we follow that, that goes back to the board to this box here. What is that box? DLB. Don't lose the beer? What's DLB?
Double broiler.
Double line break. What does that mean? Why is it there? Does anybody have an idea why it's there?
That would be to, I know you had explained on the last video on the, with the, on the heating elements on top of the stove, that controls the temperature. Double line break is like, you got that bimetal in there that will allow the oven to go from, will fluctuate from like low to medium, and then when you turn it off.
Well, we don't have low to medium, and I'll get to that in a second. Okay, so let's say this is the computer board. And I'm gonna go ahead and draw 2 relays. Bake and broil. Right here. Now I'm gonna do it this way, as this is how it was done old school. I mean, like when they first started doing electronic controlled ovens. These are newer designs, and a lot of them come out like this now, but how did they come before? So we had line 1 come in, and line 1 went into one relay, and also went into another relay. So what happened is they had a switch here, and they had another switch here, and then this one just went to a bake element, and this one went to a broil element, and went to line 2. If I wanted bake, I close the bake relay, this one comes on. If I want to broil, turn the broil relay, and the broil works. So what's wrong with that? Is there anything wrong with the way that operates?
I mean, would you have like, can you be able to set the temperatures? I mean, they would both be the same temperature, right? You don't have no
Well,
way to set
when we
the
broil, we don't use the bake element. I'll talk about using the 2 elements during the bake cycle in a minute. But no, that's the way it was, and that's the way it works.
Say if I want to bake 250.
It doesn't matter. The sensor here, the little thermistor is going to say 250, and that's going to shut off.
Okay, got you.
That's all. The sensor tells the board the temperature, and it turns that relay off. And now it's off, so what happens to the temperature of the oven? It starts cooling down, and the sensor says, hey, let's come back on because it's cooling down, and then the relay closes and the element comes back on. That's simple. But that meant that these 2 wires here, the orange one, would go right back to line 2 here, which is my drawing. It goes right back to line 2. So what was happening is that someone went to the house and saw the bake element was not working, and they'd unscrew the element from the oven, and if we went back to our picture here, you could take these 2 screws off here and pull the oven out, and if you pull it slowly enough, the wires will come with it. You can unplug the wires, connect them to the new element, and put it back in there. We don't do it when it's plugged in. The power is off. But the old school way, if you pulled it out and left it plugged in, one of them wires has got power. It's directly to line 2. It's got power all the time. So they said for safety reasons, we got to put a switch on line 1 and a switch on line 2 to make sure that don't happen. The other reason was, like microwaves, we put more than one door switch because if one of them fail and the other one shuts off, we don't have elements running all the time. So if we go to this circuit here, if that relay got stuck, even though the board is trying to turn it off, that element's always on, fire hazard. So if we redo this circuit, and let me see here, if I go like, oops. I didn't want the whole thing. Oh, now it broke it down. Not the way I wanted it. But anyways, if we wanted this circuit like this, it does not want to, let me try one more time.
Once you copy it, don't select again. Immediately drag.
Yeah, but it doesn't have the cursor.
It should have it highlighted and allow me to. So once you paste, don't click cursor.
It don't do it though, because
Now just directly move it.
let's see if I can do it from here. There we go. So what they did is they took this line 2 here and they added another relay, just a single relay on the control board, and then line 2, DLB. So if you had an oven that the broil element and the bake element didn't work, one of the one things you want to check to see if that relay is working, because if that relay is bad, neither element will come on. Okay, that happened a lot on some Frigidaire ranges. Not that they would go bad right away, but over a long period of time, that relay would fail, and then the customer would have no bake or broil. Because it's very rare that both of these relays would go bad, and both the elements would go bad. So you didn't have either element work. This will be, so the double line break control both. If you have bake but no broil, or broil but no bake, let's just say bake but no broil, it's either this relay or that element. Okay, if you had broil but no bake, it's this relay or this element. But if they both don't work, what's the odds of both elements being bad, or one relay and one element being bad? You gotta find that one common thing that they both have. And most likely it's that relay on the board. Yes, sir.
Is the broil element always on the top?
In the oven, yes, sir. The top of the oven is always broil, and the bottom of the oven is bake. Okay? So, let's go to, okay, we did these 2 circuits here. Let's go to this circuit here. So this is the corrected circuit. Now what I want you to do is I want you to pay attention to here. Bake has 2 asterisks, broil has 1 asterisk. What is that telling you there? What's that information on that chart telling you?
Bake alternates with broil, the one called for heat.
Bake alternates with broil when calling for heat. So the legend here says cycling contacts. I know that doesn't look like that star there, but that's what it is. But those contacts cycle. In other words, when we're cooking, the double line break relay stays on the whole time we're cooking. If we're broiling and the element needs to cycle on and off, that's done through that relay right there. That relay will open and close, cycling the element on and off. If we're baking, we go between the broil element, which here's the broil circuit, and I'll do them different colors. We go to the broil element, and it comes here and down and through the broil element, through the double line break and out. Now, what happens is it's going to switch to bake, and then this relay here will turn off the broil and switch to the upward position and go through bake here and out that way. So when we bake, they turn on the broil element, but even with mechanical ovens, you can't turn that broil element on red hot. It comes on for a very short period of time, seconds, and cycles off, and the bake comes on. The bake is the majority of the job when you're baking a cake. But if you have a big sheet on the bottom of the oven that you got a cake on, and the element's heat from the bottom, even though the pan is there, it reflects some heat, but it gets hot, and then the rest of the heat, natural convection, flows around. The top of the cake does not cook as fast as the bottom of the cake. So if we baked and just used the bake element, we would overcook the bottom and undercook the top. So what they do is they turn the broiler on for just a little bit to try to even out the heating inside the oven. And we talked about that oven vent. That oven vent that's running here inside this oven. Without that oven vent, remember we talked about the gasket on the door in the other video, we need to have that airflow. This door cannot be airtight to the oven and cook. It's not like a Tupperware container. It's got to have natural air circulation or we won't cook properly. So that airflow comes out right about here. You guys have to take a look at it when I'm done with the lecture. There's a vent right here and that heat comes out. You might even see this turn a little yellow if they self-clean a lot. This will actually turn color from the heat. Okay? Now this is not a self-cleaning oven, but if it did self-clean inside of this tube here in the oven, let me see if this one has it. No, this one's just a hole. But in the oven, you're going to see a screen. The screen acts like something in a car. What type of screen is in the exhaust of a car?
Filter?
It's got a name. And if people take it in to try to get money, it's very expensive if you can.
Catalytic converter.
Catalytic converter. What's the purpose of the catalytic converter?
Eliminate smoke.
The noise.
It burns smoke. So catalytic converter, when they designed that for the cars, it was supposed to get so hot that any smoke from the engine gets burnt so that the exhaust looks clear and doesn't put out a lot of smoke. They put catalytic converters in the screen of the oven so when we self-clean, the metal gets so hot it reduces the smoke from the grease when we're self-cleaning.
It's supposed to be made out of platinum.
It could be, I don't know.
Yeah,
In
it
the
is.
sense of ovens, they use enriched palladium as a catalyst because palladium's more expensive, but you can make it thinner and it lasts indefinitely. Where platinum is technically cheaper and you can get away with it. They used to in the 50s use rhodium and then that got insanely expensive and they stopped. But now they do a bunch of shutters that I was looking at a different unit and I couldn't believe how complicated it is.
So the self-cleaning in the oven prevent the smoke from coming out.
Can I mess with him? I
So-
know you
These
gotta
older
pull my
ones in the
dictionary
guide,
out for
it
him.
actually tells you not to put your hand there because you'll get burned.
No, I got you. I got you. I'm just messing with you. I gotta pull my dictionary out for your ass. Rhodium.
And another thing that with these broil elements, they always happen to be 1,000 to 1,500 watts hotter than the bake element at the bottom.
Well, how many watts is this one? 900.
Yeah, about 900.
Why are they higher wattage?
The bake element, high wire?
No,
The broil.
the broil element's a higher wattage than the bake. Look, that's 3,400
Mm-hmm.
and that's 2,500. Why has one element got more wattage than the other? We don't even use the broil that much. I mean, the only time we use broils if we're broiling steaks, pork chops, or fish, or something like that. Or we turn it on.
That's a lot more
and
power.
we only turn it off for a few seconds. Yeah, more wattage means more power, but why? It's 1,000 watts more. I mean, you got a stereo system in your car, and I pull up another car with 1,000 more watts than you.
Yeah,
I'm gonna be louder.
that's right.
But why?
But then I'm looking at the ohms. The ohms, the resistance is not that much off, though. You know what I mean? The
Well,
resistance-
on a stove, there's 3 types of cooking. There
He's
is
actually onto a little detail. The amount of loops in the coil. Look at the one on the bottom that goes a very minor loop, and the one on the top has almost a W loop.
Yeah, I got you. Yeah. Mm-hmm. Yeah.
Normally the stuff you broil, you want to make a crust, you want to flash heat it and get the heat out quickly.
Right.
If you have too much heat at the top for too long, like he says, you end up with rubber food and it burns
It
right through.
seems as if you more or less like you're evening out what all the power is being evenly distributed. Basically, like a microwave antenna, it's like evening out.
that's radiated.
Yeah.
But let's look at here,
Yeah.
okay? So we have 3 different types of cooking:
Okay.
conduction, convection, and radiation. Which type of cooking is cooking from conduction?
I don't know that, but I know.
I gave it in the last lecture.
Convection is when you got.
No,
you got
conduction.
that. Okay, I don't know.
Conduction was the glass top or the coil burner on the top, and then you had your pot here, and then the heat heats up this, then heats up your pan, then your pan cooks your food. So the heat has to conduct from the burner to the pan, then into the food. So that's cooking through conduction.
Okay.
All right? Convection. Which one is convection?
Airflow, heat and airflow.
No, but there's convection inside of here. I have no fan in there.
No fans in there?
There's no fans in there. It's not even a self-cleaning oven.
Well, okay.
Convection is natural airflow.
Oh,
So
okay.
when you're
Hot air
baking,
rises, cool air comes down.
if you're baking, and this is your rack,
Oh, I thought you were drawing something else.
and then let's just say you got your turkey here.
Boy, stupid. He is drawing something.
The heat here rises up and creates a natural convection around the food.
Yeah, okay.
So baking is considered convection, where as the hot air rises, comes out our oven vent. Remember I showed you the door last week that the gasket allows fresh air to come in, so it's constant natural airflow through convection.
Natural airflow.
That's natural convection. Now we have ovens with fans, which is forced convection. It's a fan that forces the heat on, and that cooks even faster. Most of the times when you go to a restaurant, if you ever notice when they cook like a steak or something like that, when you cook it at home, it's never the same way they cook it at a restaurant.
Oh, man.
Well, they cook it at 500 degrees, not 300 like we do at home. And they cook with a convection fan. And a convection fan heats the outside of the food so fast that it sears it and it traps the juices inside. So you get that crispy charred taste on the outside, but you get the juicy taste on the inside. When we bake usually at lower temperatures, and that tends to dry out our food. So that's why we don't have such juicy food. So if you could buy a convection oven for your home, you're actually gonna have better tasting food, and it's gonna cook faster. A lot of times when you're convection baking, you have to go about 20 to 25 degrees lower. So if it says bake a cake at 350, you wanna bake at 325. Because you go at 350, you'll burn the cake if it tells you to cook for 25 minutes. Okay, so you got to cut down 20 to 25 degrees in this. Now, I know I'm going over a lot of stuff like conduction, convection. It's like, okay, big deal. I don't need to know that stuff to fix the oven. But I remember one day going to a lady's house, an old lady, cooked cookies for Christmas every time. And she got a new stove, and her new stove, cookies weren't coming out right. She blamed the stove. Well, you know that loading and the actual colors of pans make a difference. Darker pans get hotter than lighter pans. Lighter pans reflect more heat. And if I've got this, let's say this oven, well, that's not what I wanted to do. Let's try that again. If I had a rack here, and I put two cookie sheets side by side there like the oven, and my element's down here, I'm blocking a lot of the heat. So the bottom will cook and the top won't get enough heat. So if I'm putting two cookie sheets in there, you put one cookie sheet on the rack on the bottom, like here, and then you have the rack above it, you put another cookie sheet here so that you allow flow. And sometimes the problem with the oven is not that the temperature is wrong in the oven, customer is using it improperly. And the lady corrected me 3 times, so I explained to her. She says, you know, I've been cooking since before you were born. And I said, yeah, but I went to school to learn this. Did you go to cooking class? And I didn't say it that way. You know, I mean, you can be rude and do it. But I said, ma'am, I was trained, and if you don't stagger them, you're actually going to cause poor cooking results. And if you have different color pans, one's going to cook better than the other.
Did you know that, or she told you that?
No, I told her that she was cooking them wrong.
Mm.
But I had to say, can you show me what you were cooking at the time you had the problem? I didn't tell her ahead of time. Oh, I had these cookie sheets. I said, well, show me Show me how you did it, because I need to see how it was working so I can try to figure out what's wrong with it. And then after, I had to explain to her what was the right and the wrong way to do these things. But knowing all these little tiny bits of information may not seem that important, but they all add up to fixing the stove.
Mm-hmm.
So what's radiation?
Radiation is microwave.
Broil. You go to the beach and lay out on the beach and you get that suntan, you're being radiated from the sun. The heat's coming down on top of you the same way the broil element does. The broil element cooks from the top and radiates the heat down onto your steak or whatever it is, you know. Got a little T-bone in there, making me hungry now. But radiation is cooking from the top. So how do we troubleshoot something like this? How do we, let's say the oven's not working and the customer tells you, hey, my bake element's not working. What do you do? Go to the back of the stove. My bake element's not working. What's the first test you should make? Everything else is working.
Ohm it out.
The top of the stove's working. The bottom. You can ohm it out. We can ohm out the bake element. Put our meter leads right on these two terminals. What other test could we do?
Okay, we got the bake element, we got that relay going to the bake element, right?
Okay, but hold on a second. Let me go back to that diagram here. Let's go to this one here. This is a bake element right here. So I can put my meter on it right here, and I can check it for ohms. But what other tests can I do?
Okay, you see if you got power coming into that through L1 and that double line
Connectivity.
break, right? The double line break, L1
Yeah.
and double line break.
But you know what I would do first? What do you think I would do? The first thing I would do. I know the top's working. I turned it on. It got red hot. So I know I got 240.
Mm-hmm.
So I don't have to worry about power coming in. Okay, immediately. I'm not even taking the meter. I'm turning on the top. I'm seeing the elements getting red hot. I know if I don't have 240, they're not coming on or they're not getting red. Okay? So I know it's not a power problem to my stove. So what's the next test you would do? The next thing you would do? And step, not necessarily test. Because, you know, when you guys go to diagnostics, you're testing without actually taking it apart. What other tests could I do?
Connectivity.
Continually.
What?
Connectivity. You have to go ahead and check and see exactly where the power is coming from and which wire.
Yeah, I could, but I can do one more test without taking one screw out of the machine.
You could listen to a relay.
I could listen
I
to a
was just gonna say
relay,
that.
but that's not what I'm looking for. I'm going to go ahead and turn on my broil element. Like, well, why are you checking out the broil element? The problem is the bake. But if the broil element works, what is it telling me?
That your double line break is good.
My double line break's good. I've already tested a relay on the board without even putting a meter on it. I just turned the oven on and I saw the broil element get red hot. I know that I got line 1 coming to my board. And I knew I had line 1 because the board lit up, and if we went back here to the diagram here, line 1 also feeds a transformer. It would light up. Let's go back to our test here. Not only that, but I know the double line breaks good. What I have left now is a bake element and a broil relay, a bake relay, I'm sorry.
Bake relay back.
So either the bake relay or the element's back. So I put my voltmeter right on the bake element, turn the oven on bake. If I got 0 volts, what am I gonna do? I'm gonna change the board. If I got 240 volts, I'm gonna change the element. I'm done. One test with a meter, just by manually testing a couple of things, seeing what's working, what's not working. I've already eliminated part of the schematic. I make one voltage test to that element. One voltage test. If I don't have voltage test, that relay is probably bad. Yeah, a wire could be bad, but you would see if it was burnt or something. So it's either element or board. I don't have 240, it's the board. I have 240, it's the element. I'm done. One test. The same with the broil. If the bake works, I eliminate the DLB. It's a broil element, the broil relay. I check power to the relay, then the element. If I got power, the element's bad. Don't have power, the relay on the board's bad. There's not much more to do. One test with a meter. When you guys troubleshoot an appliance, it should take you no more than 15 minutes to troubleshoot, and 10 minutes of that is just taking panels off and getting to what you can test. Getting the diagram, looking at it, and making a plan to make those tests. But troubleshooting is very simple if you can look at the circuit and eliminate what you can eliminate by turning things on. Now, the other things we could talk about is adjusting the temperature in the oven, like going to plus or minus 30 degrees. And I got videos on the channel for both the GE and the Frigidaire. But if the customer says the oven temperature is not right, you can put a thermometer in there. There's a way to go in here and calibrate the control board and adjust the temperature on the oven to make sure that it matches the temperature you have inside. But there's not much to this thing. It's a big computer board, big scary thing. You're looking at it and say, I don't know what to do. I check broil, the broil works. I put my alligator clips here and here. Press bake, I got 240, okay, I need a bake element. I don't have 240, I need a board. I'm done. That's it. Anybody have any questions?
So if I go into a machine and I don't hear any relays, what would that be able to tell me?
Show me again.
That you're deaf. I don't know. I mean, obviously, if you don't hear any relays, what's the odds of that? Because you got the double line bake and the broil. So you're going to hear one of them come on. If you don't hear any of them come on, you really need to go to the board still and check your voltages.
Show me again where you put your alligator clips.
What?
Where you put your alligator clips.
Okay, so if you were checking, I put an alligator clip on the yellow and the orange wire right here on the bake element, and then my meter would check for power here. When you connect those wires, unplug the machine first, connect the leads, put your meter to voltage, something that's going to read 200 or more. It's usually 300 is the scale on most digital meters. Put on 300 volts AC, clip the alligator clips here, then plug the machine and turn it on. Don't do it with your hands on the meters. And make sure you wear safety gloves. I gave you all a pair of gloves when you started class. Everybody got a pair of gloves. Make sure you wear your gloves. Don't get electrocuted. Sometimes I catch a few of you working on stuff and you forgot to unplug it. Your hands are all inside the machine. Okay, be careful. So, there's not a lot to do. As complicated as this looks, there's not a lot inside this oven. The oven sensor is here. We could disconnect it here, or we could check it from this plug. These holes are very small. Don't stick your meter leads right inside these holes. What you want to do is stick your meter leads in the back where the wires come in, so you don't damage these plugs. You should get about 1100 ohms right here, and that goes all the way down to the sensor in the oven. If the sensor's slightly off, it's supposed to be 1100 at room temperature, and it's 1400, just change it. If it isn't anything but about 1100, 1050, 1100, change it. So they do have a toleration of about 10, 20%. So at 1100, you're talking about what, 1200? Not much difference. So if it's that close, you know, you got to know the exact temperature in here. And most of them have a chart to tell you what resistance is at what temperature. Guys got any questions on this oven or anything in the circuits? Pretty simple, isn't it?
The burner circuit is completely separate from the board circuit for the ovens?
Yes. The control board, if we go back to the schematic, which we have the full schematic here somewhere, give me a second. Like this here, there's no control board or nothing. The oven control board has nothing to do with the surface elements. Power comes in, red and black, line 1 and line 2, to each one of these switches. Here's the red one, here's the black one. This is power coming in, and that switch only goes to that one burner. And then power comes directly to this one, and only goes to that one burner. So each one of these surface infinite switches and elements are all parallel to each other. So that means they have their own circuit and they don't depend on anything else for running. The bake element, these two elements are parallel to each other off of the board. So the board only controls the bake, the broil, if it had self-clean, time bake, stuff like that. Now we have one more relay right here. Anybody have an idea what that relay is? I'm gonna go back to the schematic. I didn't actually point it out to you.
Cooling.
What is this? We got 1, 2, 3 big relays, and they're that big because of the amperage that those parts draw. Then we got this little box right here. Now this little piece here is the transformer. This was this transformer right here, which feeds the board, makes the board light up. But what is that little relay right there?
Light?
Look at the wires. What wire is this? What color is that wire?
Purple.
Huh?
Black.
No. What color is it?
Brown.
Brown, huh? Look at the diagram.
Where does brown lead to?
Just say oven light.
What?
Oven light.
It's the oven light. That's this one right here. This is that little relay right there. It doesn't say it's a relay,
Yeah.
but that allows you to turn on the light in the oven from the control board. Some had like a little switch up here. Is there a door switch on this unit so when you open the door the light comes on?
Yeah.
Yeah?
Mhm.
If we turn it around here, are there any switches around the oven here?
No.
No. And if we look at the circuit for the light, which is this circuit,
Well, it could be a reed switch, right?
well, look, if I follow this power supply here, well, this is the wrong one, but this is line 1 coming in, and going to the light, are there any other switches but that relay on that diagram?
No.
No.
That's the only one.
No, so there's no other switches. So even if it was a reed switch, it's not there in the diagram. Otherwise, that switch would be from here to here. Why? Because it would be coming off of the board and before the light. It wouldn't be after the light. So there'd be a switch right here, and I don't see any switch on that circuit. So there's no light switch for the door there. The only switch is to turn on the oven light by right here, on off.
If it was a reed switch, would the heat mess the magnet up?
Nah, probably not. They're permanent magnets, and permanent magnets really okay because remember this is outside the oven area and there's insulation between here and out here.
So if a customer were to tell me that I'm getting a paint falling off on the right hand side of the machine from getting really, really hot, could that mean that some insulation moves out of the way?
Probably. I've never seen that before. It's usually because of rust or grease or whatever.
So corrosion on the unit isn't something you normally see?
No. Only after years of use, and it's not covered under extended use. Contractor stuff. The only time rust is covered is under the manufacturer warranty. Because that's a defect in the machine, but if the customer has it 5, 10 years, an extended contract won't cover it.
So sometimes we have to know the difference between a manufacturer's contract and an extended contract.
Yes, manufacturer's contract is not exactly the same as a warranty. And some warranties, there are leeways, because you might have something where the customer damaged it, but you still replaced it for the customer. Under contracts, no way does an extended contract cover customer abuse.
Okay.
You know, customer scratches the top, well, you gotta buy a top if you want a new one. If they drop something from the cabinet above and it cracks the top, that's not covered. It's not auto insurance.
Okay. And then one more question. For
Sure.
the oven light, how come you can't drive the oven light directly from the board?
What do you mean you can't drive it? The oven light is coming off of the board. What are you
Off
talking?
of a relay.
Yes.
The same button that actuates the relay could directly actuate the light, no?
Well, this isn't a button. This is a membrane, a touch screen. So this doesn't have high voltage. And this one here, this membrane doesn't actually have a contact inside of it. Some have like a little air bubble. When you press it, you're actually crossing a diode or something. There's an actual mechanical button behind that membrane. So when I'm pressing this, there's an actual physical switch that I'm pressing behind. But that switch is a low voltage switch, like right here on the board, telling that relay to close.
So they do that so you're not driving a 120 volt load straight off of a small switch.
Well, that's what all these relays do.
Oh.
These relays allow low voltage circuitry to control a high voltage component, 240 volt circuit.
Okay. So, an example of this unit here, you could see that there's a green membrane in front of the board. Is that
That's just a plastic screen that sticks on, but it has no mechanical connection to the board.
Okay.
Now, some of them do. Some have a ribbon with lines on it, which are traces that are like wires that connect the touch screen to the board. But in this case, on a lot of the ovens, it's not really a touch panel. It just peels off like a sticker and sticks onto another board, but there's plastic behind it that actually has mechanical switches that you're pressing.
So you could potentially show up to a unit where everything technically works, but the buttons don't. And that could just be that little membrane is damaged instead of just the
Well, not
entire
this
board.
one. Membrane on another
Let's say a
unit.
Samsung unit.
Yeah, not this one. This one here. On some of the wall ovens and stuff, they actually use membranes, and that membrane goes to a main board, and that actually sends a low voltage signal to close those relays. Yes, sir.
All right, you see the board with the relays on the double wall, like a wall oven, is on the top too, right? It's not
Yeah.
like in the back on the standing.
Well, on some of them, there's a relay board in the back, and the whole oven has to come out. A lot of manufacturers, though, a lot of them put all the boards on the top, where you may be able to get to it by just removing the front, or maybe pulling it halfway out where you can get to that components from the top.
And in the situation where we run into a wall oven that has an integrated microwave, I've seen that being really in vogue right now.
That oven right there has got a microwave on it.
Let's say I had to get the information off of that. It would be the information that's labeled on the microwave or the information labeled on the oven?
What are you talking about, model and serial number and
Model
stuff?
serial.
Usually be around the oven control area, not so much the microwave. And on some of those units, the microwave looks like it's part of it, but they have actually microwaves that are bolted to the oven.
Okay.
Carly, you can